Hello everyone, welcome to this series again, and over here we are going to learn about SMOTE. In previous video we saw that we have highly imbalanced data where only 10% of the total volume we had fraudulent transactions, rest 90% was in non-fraudulent, okay, which means the genuine one. Now we learned balancing that data using oversampling and undersampling just by duplicating the records. Now over here also we are going to learn the oversampling the minority class, but not just by duplicating but by creating the synthetic records. Now how does that synthetic record works? Synthetic record creation works is that is based on k nearest neighbor, right? So behind this story of this particular model, which is none other than SMOTE, k nearest neighbor works. What it does is from the minority class it picks one record, right, and for that it will find the k nearest neighbor, and basis on that it will try to create some synthetic record for that, and that's how it tries to balance the data. Creates the balance between non-front minority and majority class. All right, so that's exactly what we are going to see over here, how to do this. Again, I'll repeat, SMOTE stands for synthetic minority oversampling technique. So to use this, it is important that you have this particular module installed in your system. In case if you don't have it installed, just run this syntax and you would have that, you will get that installed. Now after that, once this is installed, what you need to do is you need to import it. So we're gonna say from imb learn, from imb learn dot oversampling import SMOTE, right? So once this is SMOTE, once this is imported, we need to create an instance for this SMOTE, and we will just quickly create an instance for this. The instance is created. Now it's time to create in this also we would require to create trend test split. So before that we need to have two set of data, right? We should have the data is splitted in two part. One is for target and the other one is for the independent features, right? So what we had created in the very beginning, that's exactly what I'm going to utilize over here. You see this one, this is the segment I'm going to utilize over here, right? So to create this SMOTE, I would say x underscore SMOTE, then comma y underscore SMOTE, and over here I'm going to say SMOTE dot, here it has this function or method, you can say fit resample, and inside that you need to supply this data set, right? Independent is the set of all the features and dependent is nothing but the fraud flag. Okay, so this is what we need to supply, and after that it will be created. Let's quickly check the shape of the data, right? So for example, independent dot shape, and over here I'm going to just put it inside display so that we will be able to see other printing work also. X underscore SMOTE dot shape. Now what you see over here is this is true, this is what we had, 88,213 total independent, total volume of the data, out of which these are just set of the independent features. So for dependent and independent, total number of records are going to remain same, right? So what it has done is it has done the balancing and it has created 1,60,000 records, which is nothing but 160,000 records, right? Now next one which I'm going to do is I'm going to create display, and inside that again I will use dependent dot shape, and after that display, here I'm going to say y SMOTE, right, dot shape, and let's see, bravo. So it also has the same sort of distribution. Now the next thing is creating the trend test split. Again I'm going to take this one from here itself, I will pick this, and this time over here instead of keeping this set of data, we will use this x SMOTE and y SMOTE, x SMOTE and y SMOTE. So this is what we are going to use for our training purpose this time. All right, now this is done. Next thing which we need to do is train our model dot fit, and inside that I will use x train comma y train, and this is done. Then next thing which we will do is, of course, we will do the prediction dot predict, and inside that we are going to say x test, and let's put it into the prediction, right? And this is done, prediction is done. Next, let's try to put the create the confusion matrix, and for confusion matrix again I will use, first we would require to create, of course, accuracy test, right? And over here I'm creating the accuracy test, and then I'm putting that into the heat map. Over here you see accuracy test, and then these are the parameters to create the heat map to make it interesting. Okay, and let's just see what we get. All right, this looks pretty well. Now let's just see the classification report. Classification report, and into this one we are going to use y test comma prediction, and let's just see what is it that we get. Let's say prediction, sorry, not prediction but print. All right, so what do you see over here? Wow, this looks pretty cool. Everything is pretty much in sync. Accuracy is 91%, F1 score is 91% for both of the class, and recall is 90% for this class, minority class, which was the minority class, and 91 looks for majority class, right? So this looks pretty much in sync, isn't it? So this is how you see, I mean, it's quite good technique to use to balance our data SMOTE, right? So I highly recommend you to utilize this in your data balancing work. So this is what this is it in this video. In the next one we will try k-fold cross validation and ensemble technique, right? But this is one is this one is very, very useful. Do try this exhaustively, and I mean extensively rather, I should say. Okay, and let me know what is your experience into the comment section. In case if you find there was some of these steps which could have been handled in much better way, do let me know. I'll also learn it from you. Thank you very much for watching this. Wish you good luck. Let's catch up in